We start exercise with this question. There is a spherical object and it has got bulk modulus of elasticity B. It is subjected to a uniform pressure P. Like we dip it in the water or by any means the pressure is applied from all the sides, so its volume will become less. Okay. It is the fractional decrease in the radius. This is required. Fractional decrease in the radius. If the volume decrease, naturally the radius will also decrease. So if initial radius was r, the change in the radius is delta r. Then what is fractional decrease? Delta r upon r is supposed to be fractional decrease, and they are asking us the fractional decrease in the radius is equal to one of these three. So this we have to find in the terms of what? P and B. P and B everywhere. So this is the problem. Now the question is asking about radius. What is being decreased is volume. And we know volume and pressure, they have relation with each other. Elasticity B. That B, what is the relation of B? Bulk modulus B is equal to stress, force upon area divided by strain, that is delta V upon V. So force upon area is pressure, so this is pressure upon delta V upon V. If we take delta V upon V on this side and transfer B on this side, what do we get? Delta V upon V is equal to pressure upon B. So we remember it as equation 1. Now we come here. This is not the answer we need. We need answer decrease in the radius. Now what is the relation of radius to volume? The answer is volume is equal to 4 upon 3 pi, which is a constant, r cube. Right? Now we have studied in the chapter of errors that what is the fractional change in volume, delta V upon V, that will be equal to 3 times delta R upon R. Right? This is the relation. By differentiation it had come, and this we know. Now this delta V upon V, you see in 1 and 2 delta V upon V. So P upon B is equal to, yes. So what is, if these two are equal, then delta R upon R is equal to 3 P upon B. Where should I write 3? Very good, denominator. Right. Because these two are equal, so delta R upon R is equal to 3 will go to denominator, and this is option number D. So here we get it like this. Okay, and now we go to the next question. This is the question. Please read it. U-tube, both ends open. It is partially filled with water. So we have a U-tube. Let us say this is a U-tube. This is partially filled with water. So when we fill it, the level is equal on both the sides. After that, oil is poured in it. When oil is poured in it, what happens? The oil presses this level. So this level goes down and this goes up. This is the original one. Okay, let's leave it. I will make another diagram here. Okay. From this level, this is the original level. Read it. Water rise by 65 millimeter from original level. So water rise here by 65 millimeter. This is 65. Okay, so water comes up to this level. Now can you tell me, we have to think, if it has risen 65 here, what will happen to this level? This will decrease, go down. How much? Same 65, no doubt about it. So here we make it 65 this side. This is how much? 65. And here is the water. Okay. This is the water level. Why it has happened? Because oil is poured on this side and here is oil. What is the level of oil? In equilibrium, oil is 10 millimeter higher than the water level. This is the new water level at equilibrium, and from here the oil is 10 millimeter higher. This is 10. Okay. And this is oil. This is water. This is the final situation. Okay. This was initial, that was final. Density of oil. We have to find out density of oil. This is our question. Now, how to start it? Always look for a word equilibrium. Search for equilibrium. There is an equilibrium. Equilibrium means what? Equilibrium here means neither the fluid is going this direction nor it is going in this direction. That is equilibrium. Why it is not going this way or that way? That means at the center point here, at any level, the pressure of this column is equal to pressure of this column. That is why it is in equilibrium. Is this clear? Yes, okay. Now, whenever we find in physics, what we are always searching? Equation. In the numerical, what we are searching? Equation. Have you got the equation? What? Pressure from this side equal to pressure from this side. You got the equation. So first thing, see the situation, make the stories, and on the basis of that story, try to create equation. That equation should involve the quantities which are given to us. If you think of 2-3 equations, choose that one particular which is using the quantities which is given here. Anyway, now what is the equation we have got? Pressure by left column is equal to pressure by right column. P left is equal to P right. Now, common we can leave. That means common means what? This level. Below this water, same height. Leave it. So, the pressure of this is equal to pressure of this. Right? Yes, sir. Now you can do it. What is the formula for pressure? H rho G. Right? Here, how much is the H? Calculate from the diagram. If you have made the diagram very clearly, it's very easy. Very good. 65, 65, 10. H left is, right, you got it. Rho you have to find. Density, write it D. So 140 into D into H rho G is equal to, on the right side, up to this much, how much it is? 65 plus 65. 130 into rho. The answer is given in the numbers. kg per meter cube. Therefore, we must know the density of water in kg per meter cube. How much is that? Yes, we all know. It is 1000. 1000 kg per meter cube is the density of water. So that we write here water. This is for oil. This is for water into G. Okay, so what is D equal to? Find out. Now it is easy. Very good. So this is our right option, 928. Right? So what we have used here, the pressure H rho G. Only thing is, you should not get disturbed by this. Try to make a clean, clear diagram. Then things are very clear. Okay. Now we go to the next question. There are two non-mixing liquids of density rho and n multiplied by rho. So this is denser. Are put in a container. If in one container we are putting it and they don't mix up with each other, so we have it like this. H, H, this is the one and this is the other one. Tell me which is rho and which is n times rho. Which is rho and which is n times rho. Bottom is n times rho. Why? Because denser, and denser is always at the bottom. And this has density rho. Both have got height h. Right. A solid cylinder of length L, density D is put in this container. Cylinder floats by keeping the axis vertical. Okay. Length P into L in the denser liquid. Rest will be in the rarer liquid. So how is the cylinder here? The answer is cylinder is here. So equilibrium, this cylinder is in equilibrium. That means floating equilibrium gives us one equation. The weight of the body acting downward is equal to the upthrust made by the liquid upward. That is the equation. And in that equation, our quantity should be there. Then only this equation will work for us. So first we write the equation. What is that? Weight is equal to upthrust. Weight is equal to upthrust. Now, upthrust is given by what? Upthrust is by fluid. Weight is by body, solid. Now, what is the formula for weight? M into G, mg. M is not given, but length etc. is given. Can you convert M further in terms of density? Why we are converting? Because what we are supposed to find out is density of the cylinder material. Yes. What is that? Volume into density. In the volume, again, we want to use this length. What is volume equal to? Area of cross section multiplied by length. So, weight of the body is equal to area multiplied by length. This becomes volume multiplied by density. This becomes mass multiplied by G. This is the force acting downwards. Is this point clear? So I have not written the intermittent step. What is the force? mg. And what is m? Volume into density into G. What is volume? Area into L into D into G. This is equal to upthrust. Who is creating the upthrust? Both the liquids. How much upthrust they create? According to the volume displaced. Now, how much volume of this liquid is displaced? How much is this area? A. How much is this length? Area multiplied by length is volume. Right? Multiplied by density. Whose density? Density of the liquid. Because what we are calculating? Upthrust. In upthrust, multiplication in the volume is to be done by density of the fluid. So, in upthrust by upper liquid is how much? Area multiplied by L minus PL. This gets the volume multiplied by density rho G. This is the upthrust by upper liquid. Right? Now, upthrust by the lower liquid. This is, be very careful. How much it will be? Again, area A. How much is the length? P into L. P into L. Volume into N rho. That is density multiplied by G. So this is upthrust. Clear? Upthrust by upper liquid of density rho. This is upthrust by the density N rho. Do the cancellations, find out D. Answer. What will be cancelled? A, G, A, G, A, G. Rho, rho. Let's keep rho as common, because you see in the answer everywhere rho is out. That means rho must be common. So let we also not multiply rho. We will keep it as common. Rho. L minus PL plus P into N into rho. P into N and rho is here. Rho is taken as common. Divide both sides with L. D. Divide with L. P into N into L. L. So what do we get here is 1 P N rho. It is still not matching with the form because they have given P outside, a small bracket, N plus 1 minus 1. We will do it here. Take P outside. If we take P outside, what this will be? 1 minus N. Is there something like that? Pardon? 1 plus N minus 1 P. How? Something wrong in our calculation? Take minus out. So this will become 1 plus N minus 1 P and rho. This is matching C. Right? So what you need is a little mathematics, but the first thing in physics, what you need to have? Equation. And in equilibrium, you have to find that quantity which is creating the equation. Here, what is that quantity? Pressure from both sides. Sorry, the weight equal to upthrust. Why? Because it is floating. So in floating condition, what is the equation we get? Weight downward is equal to, in case of U tube, what is the equation we get? Pressure from one side is equal to pressure from the other side. So in physics, every situation gives you one equation, and what you prepare in a physics is which is that quantity which will give you the equation. Right? Okay, now we go to the next question. It is a chapter of surface tension. Okay. Now the question is, a rectangular film of liquid is extended from a particular size 4:2 to the final size 5:4. The work done is so much. What is the surface tension? So what are the quantities involved? Area, energy, surface tension. So do you remember any formula which have these three quantities? What is that? Surface tension multiplied by change in area is equal to surface energy. So let's write that. Surface tension. Okay, please put the values and find surface tension. Now here you have to take care that everything should be in SI system. That is the only precaution you must have. So surface tension T into area, that area we have 4 into area means what? Change in area. Area means change in area. Change in area, final area minus initial area. What is the final area? 20. What is the initial area? 8. And what is the unit? Centimeter square. So we convert it into meter square. 10 to the power minus 4. This is what? Change in area. Right? That is equal to surface energy. Is it given in joule? Yes. 3 into 10 to the power minus 4. Now you can find out surface tension is equal to 0.25. Is it there? Yes. Okay, so this is how you get it. In this equation comes from your memory by the formula. Right. Now we go to the next question. Look for this question. Coefficient of linear expansion of brass and steel are alpha 1, alpha 2. Alpha 1 for brass, alpha 2 for steel. Lengths are L1 and L2. Okay. If L2 minus L1 is maintained same at all temperatures, when we heat them, the brass will increase in length and steel will also increase in length. But what he says, both are increasing same. That means their difference between the two remain same, whatever is the temperature. Then which of these relation is true? This we have to find out. Okay, so what is the relation given to us? How will you make equation in this? Equation in this, think. We take the length difference normal. How much is that? L2 minus L1. Then we heat it to the same temperature. The length will increase. L2 dash minus L1 dash. What should be the value of L2 dash minus L1 dash? Same, equal to, you got it. L2 dash minus L1 dash after expansion is equal to L2 minus L1 before extension. That is the equation. Understand how to think for the problem? That is very necessary that you search the equation. What is given there? The difference of the length remain same, and this which remains same, this gives you equation. Wherever there is same, what is behind that? Equal. So if this given same, write equal. Now what are the two things which are same? Difference of length after heating, difference of length before heating, and that is equal in between. That is the equation. Once you have thought it, you have done half the job. Right? And that is your physics knowledge. So here we have seen same, equal. So here we will write difference after heating is equal to difference before heating. And now you have got it. What is difference before heating? L2 minus L1. Simple. Coefficient of brass steel rod are this. Lengths are L1 and L2. So what is the difference in the length? L2 minus L1. This is equal to difference after heating. Now comes your second knowledge. Do you know how much length become after heating? L is equal to L naught plus alpha that you have written. What is that? Tell me. L2 plus, what is that formula? No. L2 1 plus alpha T. L2, should I make a plus? No. 1 plus alpha 2 into delta T. This is what? Expansion. No? What should I write? Alpha into delta. Is this right? Yes, but this formula is okay. Alpha value is how much? 2. Delta t, we have to take same for both. Okay, so L2, 1 plus alpha 2 delta t. This is the expansion formula. This is something we should come from our memory. Now, length 1, how much it has become? Length 1, 1 plus alpha 1 delta t. This is the length of 1 after. What is the difference between the two? This is the difference. Minus. So this is the difference after heating. This is the difference before heating, and that should be same, equal. Right? So here it is. Now you have to find it in the equation form. That means you simply have to make simplification. Do some simplification so that it comes into this form. What is this form? Alpha 1 upon alpha 2 is equal to L1 upon L2, or alpha 1 upon alpha 2 is equal to L1 upon L2. Everywhere it is same. So you also try to get the same format here. Please, let's proceed. L2 minus L1, L2 minus L1, cancel. What do we get here? Right? Now, how many terms? There are only 2 terms. Delta t take common, that is also cancelled. Delta t, delta t. Alpha 2 L2 minus alpha 1 L1 is equal to 0. Transfer it to this side. So this is like this. Right? And you have got it here. Alpha 2 L2. Alpha 2 L2 is equal to alpha 1 L1. Alpha 1 L1. So we have this option C.
Sir, only 1 alpha 1 minus alpha 1
Minus
only 1
delta t. Right? In this question, there are 3 liquids. Density rho 1, rho 2, rho 3, and rho 1 is highest density, lower. Same surface tension, all of them. Surface tension T. Rise in the same height in 3 identical capillaries. The angle of contacts are different. Theta 1, theta 2, theta 3. And what is the relation between theta 1, theta 2 and theta 3? Which are the quantities? What is the case? Case is that a liquid is rising in a capillary. Which are the quantities involved? Surface tension, density, theta. So, do you remember any formula of the height with relation to? Yes. What is that formula? Yes. The height is equal to 2 t cos theta divided by density g and radius. This is what we remember for height of the liquid in capillary. Now in this, they say height is same for all the 3 cases. Is it? Rise to the same height. Okay. Now, in 3 identical capillaries, Identical capillaries means radius is also same. Same surface tension. T is also same. G is same. Height is same. Okay. So height 1, height 2, height 3. If these three are same, then this formula for all the three will also be same. Now cancel out the same things. 2, T, G, R. If these are cancelled, what do we get? For liquid number 1, cos theta 1 upon is equal to now this equation you got. This is your physics part of it. When you see a question, apply your physics knowledge and make an equation. So this is a surface tension, and what we were looking for it. See here. Same equal. What is equal? Height, height, height. We write the height formula 3 times. What are the similar quantities? 2, G, R. What are the different? Theta and rho. So we make it theta 1, theta 2, theta 3, rho 1, rho 2, rho 3, and make equal. We got the equation. Right? Our half job is done. Now after that, what we are supposed to achieve? All these three are equal. That means this is equal to a constant. So cos theta 1 is proportionate to rho 1, theta 2 is proportionate to rho, cos 3 is equal to rho proportionate to rho 3. That means there is a general relation, that is this. Cos theta is proportionate to rho. Is that clear? Okay. Now see the sequence of rho. Which is greatest? Rho 1 is greater than rho 2 is greater than this is given. If this is given, tell me the value of theta. Theta 1 is more than, because they are directly proportionate. If rho is more, theta is more. So theta 1 is greater than theta 3. No. One serious mistake. Not theta, cos theta. Cos theta 1 is greater than 2 is greater than cos theta 3. Now you tell me, if the cos is increasing towards 1, what is happening to theta? Yes. Theta is 0, cos theta is maximum. So if this is the relation of cos theta, what will be the relation of theta? This cos is maximum, this theta will be minimum. So we have here theta 1 what is the maximum value and minimum value of theta? Theta minimum. Theta minimum. Not cos. Minimum theta 0. For which cos will be maximum 1. Right? Theta 1 is smallest. This can go up to 0. It may be 0, larger than 0. Now we go up. This is the highest value. So in surface tension, what can be the maximum value of theta? 90 degree. So 90 is what? Look for this. Which one? B. Yes, 0, theta 1, theta 2, theta 3. right? Pi 2, no, this is, okay? So, we can assume it, this can be, this is the nearest one. So, what is that? B. So, B is our right answer. Yes. So, this is how we decide about it. See this question. A wind with speed 40 meter per second blows parallel to the roof of a house. Area of the roof is this much. Inside room there is no airflow. How much force applied on the roof and in which direction? Which chapter it belongs to? Bernoulli's principle. We did it in Bernoulli's principle, that why the roof flies when there is a wind. What we are trying to find out? The force. And in Bernoulli's theorem, what we study about? The pressure difference due to velocity. Right? Pressure difference due to velocity. What is the relation of pressure and velocity? That comes from our knowledge of physics. What do you know about it? According to Bernoulli's principle, P1 minus P2, Bernoulli's, is equal to half rho V2 square minus V1 square. Right? You remember this? Okay. This is the pressure difference. And what we are trying to find out? Force. But we know the relation that force is equal to pressure into area, and area is given to us. So what we are supposed to find out? Pressure difference. If there is a roof, what is the pressure difference here and here? If that pressure difference is upward, then there will be force up. If that is downward, there will be force downwards. Okay. So that we are supposed to find out. Now if this is the roof, what do you want to take here, P1 or P2? P2? Okay, then what is the velocity? V2. Pressure P1, and what is the velocity? V1. Okay. Why P2 should act downward and why P1 should act upward? Because the general principle is pressure works in all directions. So whenever it is having contact with a surface, it works in the direction of the opposite direction. Like this room has air pressure. What is the direction of pressure on that wall? In this way. What is the direction of pressure on this wall? This way. These are opposite. So the pressure always acts in the direction opposite to the contact surface. Right? That is why here pressure 1 is here, the pressure 2 is here. Okay. Now, this is our equation, pressure difference of the two. Put the values. What is value of this? Will be half. Should we make it 2 to 1? 2 to 1 or anyway 1 to 2, let's keep it like this. Half rho is common. This is V2 square minus V1 square. This is equal to half. What is density of the air? Any idea? What is velocity? V2. V2 is given as 40. 40 square minus V1. Inside, no airflow. 0. Okay. They should have given density of air. Anyway, if it is not given, the density of air is 1.2. Okay, so remember, density of air, how much is to be taken? 1.2 SI units. Now, do it. Yes, can you calculate? Very good. This is 960. What is this? P1 minus P2. Pressure difference. In which direction? Because we have got plus 960, that means P1 is higher. This is P1. So direction is up. Then what will be the force? Yes, 960 multiplied by P into A. 960 multiplied by 250. Okay, so this will be what? 2.4. In the examination, I don't do it fully. I will see 4.8, 2.4. What it is coming? 2.4. Yes, 25 into 96 is 2.4. Now power. Don't worry about the power because everywhere it is 10 to the power 5. So 10 to the power 5. And what is the direction? Up. Okay, what is the answer? Yes, we get the answer D. So this is how we do it. Please see this question and tell me what's happening in this. There is a spray pump, right? In the spray pump, this is a large tube in which pressure is created. So from here, the fluid is going with a velocity v. There are many small holes here. And from that, liquid is also flowing out with a velocity v dash. What is given to us? This radius is r and radius of each hole is r. Right. Now, in this, what we have to find out is the velocity with which it is coming out v dash. In such situation, what we are supposed to find out? An equation. That equation should contain v dash and other given quantities. Now we search. We search for either equal or equilibrium. In this, no, there is no equilibrium because there is flow. Something is moving, going out, no equilibrium. Equilibrium you get when the system gets stabilized. Like water in the U-tube, finally it gets stabilized, you get equilibrium. When the cylinder is floating in the liquid, what is the final condition? Nothing is moving. It stays in one state, that is equilibrium. In those cases, equilibrium. But when something is moving, this is flying off, there is no equilibrium. So we will have to look for a quantity which is same. Same before this, same after this. What is the quantity? Pardon? Volume per unit time. That is, the volume which is going out from here is equal to the volume which is coming here. Very clear. Whatever volume is going out, the same volume is coming out. So, we must know the formula for the volume which is going out and which is coming in. That formula should be related to V. And this you have already derived. You have already reached a result. If you want to, yes, that is A1 V1 is equal to A2 V2. Because volume, if we divide with length, it will be area. Length divided by time is velocity. So this has been derived as A1 V1 is equal to A2 V2 in a streamline flow.
Coming back.
Yeah. It is a streamline flow. The same liquid is going out. Right? Now, what is the area 1? Pi r square into V is equal to area 2 into n, because there are n holes here. This is the total area, and what is the velocity? V dash. Now with this you can find the value of V dash. V dash is equal to r square upon nr square into V. Do we get it anywhere? VR square upon nr square. Okay. So this is the right option. Right? Okay. So thank you very much.